Hello, people. This is Teacher Calvin, and welcome to another episode of Science I Can Do. And with our great tips, I'm sure science you can do too. Today, you're going to be watching a video conferencing lesson on the topic of energy, work, and power. So sit back, relax, and enjoy the lesson. So today I want to quickly run through the energy chart. All right. So energy is the ability to do work. Okay? Understand?
Yeah.
Okay? All right. So there are few types of energy that you need to know is electrical energy. Okay? Which is examples, electrical current in power stations. All those power stations, they produce electricity. They sell us electrical energy. Can? So you find electrical energy in all those power transmission cables, those tall towers with dangling, sagging lines or something like that, right? Okay. Steel cables. You find electrical energy there. Okay. Thermal energy we learned already, right? Okay. It is the sum of the kinetic energy and potential energy of all the molecules of a system, right? How much kinetic energy of the molecules in a system like iron rod, right? When you heat it, I told you it gets thermal energy. Okay? Hello, not heat energy. Do you understand the difference between thermal energy and heat energy? I did explain to you before. Thermal energy is how much kinetic energy of the molecules in the object. Do you understand? Heat energy is in transit. That means one object heat is moving in transit. That means like the aeroplane not transiting from one place to another. Do you understand?
Yeah.
Can? Okay. Mechanical energy is like moving objects, compressed string, bend diving board, or a stretch elastic band or a catapult. Then your light energy, we'll study them later in much more detail. All right, they come from like electromagnetic waves. Okay, again? There we have already heard of infrared, right? What is infrared? Waves is like those humans or those like living objects, right? Hello? Or any hot objects lah, they give off infrared, right? That's how the snake detect the human, even in the dark. Hello? Yes, not.
Yep.
Yeah, infrared and X-rays. You all go for X-rays. They take and then you see your bones, see any fractures or not. Okay, again, we'll learn about them later. And you see, the most powerful energy, the nuclear energy, right? Is to make atom bombs, nuclear reactors to generate electricity. Okay, again?
Yeah.
All right. So under mechanical energy, you better know two things. Kinetic energy, because when you have a machine like a fan, it just spin and to keep us cool, that's mechanical energy. But from these machines, right? Next time you do mechanical engineering, you'll probably like uni will do dealing with machines. Okay, Ken? All right, Ken? Hello? Okay, so that is you have kinetic energy.
Jangan kasih dia main sama Jack Eric.
Hello?
Yeah.
Swellen, there is kinetic energy. Now, please remember this formula for kinetic energy. Half times mass times velocity squared. Half mv squared. Can you remember that?
I know.
You know?
Yeah.
Really? How you know?
We've been through this.
Huh?
Been through this before in school.
How long ago?
I don't know. Just new.
This new this new okay. All right, that's why I say I better teach you before I get left behind. Gravitational potential energy, that means due to the height. Okay, all right, is energy due to its position above the ground. So gravitational potential energy is is mass times the gravity, yeah, times the height. Okay? Okay? That means if you, Sue Ellen, jump from the first story, because the height is first story, not likely you die, probably you break a leg, because you are like living in first story, right?
Yeah.
Yeah. So if you next time move to 20 over story, you got rich and you want to buy higher, please make sure you have window grills, because if not, fall out 22nd story because of the height, the gravitational potential energy is magnified. You understand, right?
Yeah.
Like you lived in 22nd story, and magnified 22 times. So when you hit the floor, sure die. You just don't break a leg, you probably break your head and break every part of your bones. Can you understand?
Yeah.
Now your house no window grill, right?
No.
Yeah, you don't put, right? Your daddy don't put, right?
Window grill.
Yeah.
Yeah, he puts.
Oh, because you got the little boy is scared you climb out or whatever. I don't know.
Yeah.
But you fall out, not so damaging lah, but it's bad to fall anyway. All right, so with little kids, maybe they put lah. Okay, other forms of potential energy is chemical potential energy. You know, like those batteries. Batteries, you know batteries? Batteries are chemical potential energy. Can you see? Understand now? How about the food we eat? The food we eat are also chemical potential energy. Can? All right. And the elastic potential energy, that means how much you compress a spring. Yeah. Hello? You know, spring, like nowadays, the durian season, people like to buy durian, they put the durian on the pan, right? Then the weight of the durian will press down on the spring. So once they have elastic potential energy, as the spring get compressed, you have a reading. Oh, your durian is 10 kg, pay $100. You understand that? Hello? Hey, understand not? You understand what is elastic potential energy? Like a rubber band, you stretch it, it's elastic potential energy. Understand not?
Mm.
A spring, a coil of spring, you stretch it, elastic potential energy. All right, so Noah, okay, what is the formula of potential energy? mgh. Can you remember?
Mm-hmm.
What is the formula of kinetic energy? Half mv squared. Can you remember or not?
Yeah.
Okay, do you want to take a picture of this? Or make any notes? After this, I'm going to hit the exam.
Yeah, I wrote it down already.
Oh, you wrote down so
I'm gonna write it down later.
I'm amazed. I'm so amazed. All right. Okay, so principle of conservation of energy. Understand?
Wait, stop.
Stop, huh? Can I move a little bit higher, maybe? Yeah.
Okay.
Okay, again? All right. So
Blurry. Okay, never mind.
energy can neither be created nor destroyed. Can you see or not?
Yeah.
It just changes from one form to another and transferred from one body to another. Can you see? Okay.
Yes.
All right. So total amount of energy always remains the same. All right, Ken? So like the maximum GPE, gravitation potential energy, is here, and the kinetic energy is 0. That means you haven't let go. When you let go, the kinetic energy will be increasing. Yes, not? But the potential energy is dropping. Why? The potential energy is changing to kinetic energy. Understand? So this potential energy maximum here, yes, that means before you start, you haven't even moved, the kinetic energy is 0. Get it? But the potential energy is maximum because you lift it up to the maximum height. Can you see or not? Yes. Now, when you let go, the potential energy is get less and less, right? So where did the potential energy gone to? Change to kinetic energy. Do you understand? Yes or no?
Yeah.
So potential energy lost, but kinetic energy gain. And at the bottom, you can see maximum kinetic energy zero gravitational potential energy. Can you see? All the potential energy converted to kinetic energy here. Understand, girl? Understand?
Yes.
All right. Then your ball doesn't stop there, right? It begins to climb. As it climbs, the kinetic energy becomes less and less. But when you climb, the height gets higher. It's converted back into potential energy. Can you see? So when it reaches this point, it has to rest before it turns back down. But at this point, the kinetic energy is zero, but the potential energy is maximum again. Can you see or not? Okay, huh? All right, this conversion of energy here. Mechanical energy is like the dynamo of your car, bicycle. Have you seen the dynamo of a bicycle?
No.
You see? Here. Can you see or not? Can you see this picture? Yeah. Where this is for to save battery. No need to buy because as you press a button, it will touch the wheel. You press a button, it will touch the wheel. So when the wheel spins, this guy will keep turning. And with turning inside, there's a magnet. As long as you turn a magnet inside a coil, electricity will be generated. See or not? But it's harder to cycle. Do you understand? Because now your wheels is contact with this dynamo. Do you understand how this works? When this one touches the wheel turns, right? The wheel turns. When the wheel turns, this is like a water bottle cap, no? It turn. Can you see? Get it? This cap is attached to a magnet. Okay, a magnet is surrounded by a coil of wires. Okay, and then when the magnet turns inside a coil of wires, electricity is generated. Then it will light up your lamp here. So this one no need to buy battery on. Nowadays they use the battery pack, but then last time okay, the older bicycle they have this dynamo. So this will ensure that you have battery forever as long as you keep turning this knob. Okay, okay? The wheels turn, then this one touch the wheel, this one turn, the magnet turns, the electricity will flow out. Understand, huh? Okay, so that is the dynamo. Okay, so there. Mechanical energy, like anything to do with machine, the dynamo will be converted to electrical energy. Okay, again? All right, okay? So electrical energy, like from the electrical iron, will give you thermal energy. Can you see now?
Yeah.
Okay, like electrical energy can be converted to a sound energy by a loudspeaker. Can you understand? Chemical potential energy in the battery, right, is converted to electrical energy. Can you see? Can I? Can I?
Yeah.
Okay. So of course, if you charge a battery, it convert back to chemical potential energy. Can you see? Huh? Okay, moving on. So now you must know this. Okay, work and power. Okay, now learn this. Very powerful. Work. Okay, work. The SI unit for work is joules. Joule. Understand or not?
Yes.
Okay, what is 1 joule? Is defined as work done by a force of 1 Newton. Force is measured in newtons, right? Can you see? When its point of application, that means I move it north, it moves through the north a distance of 1 meter in the direction of the force. Okay? 1 joule is equal to 1 Newton times 1 meter. So how many joules you use is how many newtons times meter. That means force times distance. See? Force times distance. Here, see the arrow? Force times distance is the work done. But the important thing is must be move in the direction of the force. Okay? The displacement means like the distance moved must be in the direction of the force. Do you understand? Okay, give you an example. Like I don't care how many kg, okay, how much weight is pressing down here. It does not matter to me. This is a useless piece of information. As long as I push this box to the right by 2 meters, then the work done is 5 newtons times 2 meters, 10 Newton meter. Get it? Newton meter, another unit for it is joules, because work done is in joules. So sometimes they try to confuse you. Newton meter is joules. Do you understand or not?
Yes.
Do you understand what I'm saying? Like sometimes you read your bottle, right? They say 500 ml. Yes, not?
Yeah.
But it's actually equal to cm cube. Do you understand? Cm cube is equal to ml. Do you understand? Just a different way of writing. Get it or not? Like half is equal to 50%. Just a different way of expressing. But they meant like the same thing, right? I got half an apple. I have 50% of the apple. Yes or not? I've got 0.5 of the apple. Can you see? Hey, understand or not? Hello?
Yeah.
Yeah. Okay, so there are different ways of expressing themselves, but joules is also known as Newton meter. The force times the distance. Can you understand this? This is very important. Remember this, huh? Okay. So the unit of work done is measured in joules. Okay. The moment is Newton times meter. Okay. Do you all know what is a scalar and what's a vector? Vector has a scalar. Scalar is just a unit, no direction one. Okay, like we have learned, right? Speed, hello, is a scalar, no direction one. Whereas velocity is a vector, because velocity have direction. Get it? So I'm asking you, where are you going to in your car? You see, I'm driving at 100 kilometers per hour, 100 kilometers per hour. That is just a speed. It doesn't tell me where you're heading. It doesn't tell me whether you're heading to Batam, which is south of Singapore, or north, which is JB. So you're just telling me you're driving 100 kilometers per hour. You understand? Are you going to Simei, Tampines, which is the east, or are you going to the west? Hello, girl. You listening or not? So if you tell me I am driving 100 kilometers to the south of Singapore, I know where you're going, right? Are you going to Jurong, Tampines?
Oh, to the south of Singapore.
Johor or Batam?
This I don't know where.
South of Singapore is Batam lah. You don't know Batam is south of Singapore.
Oh, okay.
The next definition is power. Okay? Yeah? Okay, what is power? I've got the power. Okay? The power is defined as the rate of doing work. It is work divided by time. Hello? Get it? Work is energy, right? Actually, power in that case is actually energy divided by time. Do you understand? Power is the rate of doing work. I better write for you. Power is equal to energy used up. Oi, very important, huh? Energy, E-N-E-R-G-Y, used up divided by time. Okay? It is energy is in joules, times is in seconds. Do you know? Power measurement is in watt. SI unit of power is watt. W-A-T-T. There it's written here. Power is in watt. Can you see? Power is in watt. W equal work done. Okay, guys? Work done is energy is in joules. Okay, guys? Time is in seconds. Okay? 1 watt is how much work done per second. Can you see? That means how many joules per second. That's what I've written here. Okay? Very important. Okay, we know all this, then I go and do your exam paper with you. Are you ready?
Yeah.
I hope you remember all your old stuff. Like what do you call it? Force equal mass times acceleration. Do you remember this? Newton's law. Okay. Do you remember force equal mass times acceleration?
Yeah.
Yeah. A boat pulls a fishing net with some fish.
Wait.
You read and tell me the answer.
Um, 100,000 kg. Yes, am I right?
Do you know how to do?
Yes. So force times the thing.
Wait,
Am I
yeah. All right. So what do you want? A fishing net pulls some fish for 5 kilometers, right? The force applied. What is the work? What did we have the definition for work?
F times S.
Yes. Work done is the force, right? Times the distance moved in the direction of force. So what's the answer?
100,000 kg.
What's the answer?
20,000 times 5.
Are you sure?
Yes! How's it wrong? How's it wrong? 20,000 divide. How's that divide?
Nobody said.
Wait, that's distance.
Distance. Do you
understand? Then divide by 5.
What? What's the answer? I told you this must be in Newton. This must be in meter. So what is wrong?
Divide.
No, divide. Force must be in Newton. Distance must be in meter. You still don't understand what I'm trying to get at.
Oh,
see?
right. Oh my gosh.
You just die out of nothing. So simple, and you go and die for nothing. Now you understand. It was not times 5, right? How many zeros?
So many?
Yeah.
Huh? How is that possible?
How you supposed to do? Okay. How many zeros should I have? 5 times 20,000. You told me what? Okay, let's do this. Okay. 5 times 2 is 10, right? Oh, agree or not? So how many red zeros you have?
1, 2, 3, 4, 5, 6, 7, 8.
No. Red zeros, how many?
4.
4. Okay. So 1, 2, 3, 4. Right?
100 billion. 100 billion.
This last one can be changed to K, right? Kilo is K, right? Now you compare. See what's the answer? This is K, right? Kilo is 1,000, right? Where's the answer?
D.
Yes. Can you see or not?
100,000.
Just now you were silly enough to use 5 kilometers. You need to change the 5 kilo to 5,000 meters. And 5,000, the 1,000 came to kilo lah. K stand for 3 zeros.
Yes.
So in front got 5. Yeah, 5 zeros. 1, 2, 3, 4, 5. Right? And then 3 blue zeros behind. So the answer is D. Get it or not? You use the kilometer as meters. Cannot. Understand now? Please don't get caught by all these silly things. It looks very simple, right? But can I get caught? All right. Physics always get caught by the unit. Is it okay or not? Okay, do number 2 now. An electrical appliance is found to convert 70% of its input energy into heat, right? 25% into kinetic and 5% into sound energy.
A dryer.
Ah, why is it a dryer?
Because it's 70% is heat.
Yeah, because the others
energy.
are nonsense, right?
Yeah.
Why is it nonsense? Why do you need an electrical iron to move?
There's no okay, first
Yeah,
there's
no.
no sound.
Why do you need a heater to move? Girl, you understand or
Ah.
hello? These
So
are
A.
nonsense, right?
Yeah.
Why the electrical iron need to move? Right? You need a heater to shake, rock and roll, right? A loudspeaker, you need to move, is useless energy, right? A hair dryer, you need it to move because the fan need to move and blow out the hot air. Yes, not? Yes, not? And then you need to have a hot wire inside there, right? That's why 70% is converted to the hot wire. Do you understand? Of course, 5% is useless energy, which is useless. We can't stop it because as the fan move, it just give out some useless energy, which is 5%. So what's the answer? What's the answer?
A.
Yes, A is the correct answer. Okay, again? Here. Okay, yeah. Next one.
Okay, wait.
What do you know?
Power
Power is equal to what?
is equals
Energy,
to
what?
work done over time.
Power is equal to work.
1 minute is equals to 60 seconds.
Yeah, done. Be careful, yeah. Per second, time, right? But the time must be second. That's why physics always caught out by units. Be very careful. Okay? So what is the work done? You know work done is equal to what? Hey, work done is equal to what in terms of
Work
and distance?
done is equals to F times S.
Yes, the force. And that's why physics is very good in the sense that just remember formula. Force times the distance, right? Move in the direction of the force. Okay, so what is the force? Come help me. We do together. What is force?
Force.
What is the force?
Oh, force. 2000.
Okay, wait, let's do together. You teach me. Well, I need to find power. I need to find power is work done divide by time, right?
Yeah. Time is 600.
Okay, and work done is force. Now, what is our force? Force is in Newton, right? They're lifting a weight, right? Of what?
2000.
Yeah, 2000 Newton. Okay,
What about the distance? Right.
Okay, so I'm doing with you now.
Why am I think 10?
So times the distance. What is the distance? This is meters, not centimeter, times 10. Very good. Times 10. All right, slow lah, okay? That's why the joules is Newton meters. Do you understand?
B.
Times 10. So what do you have here?
B.
2000. So now power is equal to work done, which is 2000, right? 2000 times 10, right? Divided by what's the time? 20 seconds. Okay, so
B.
which is B. Okay.
What about number 1?
Number 1 we've done already. What?
I forgot what's the answer.
Yo, you tell me how to do? Again, a boat full of fishing net with some fish for 5 kilometers.
D, A, and then A again.
Yeah, do you understand why it's D?
Yes.
The answer is 20, right? 2, okay, 2 times 10, I use indices for you easier. 2 times 10 to the power of?
Times 10 to the power of
4, right? You know, times 5 to the power of 3. Yes, not? 10 to the power what? 8, right? Is it 8? Yeah. Yeah, 8, isn't it? Hey, you know your indices, no? 2 times 5 is 10, right? 10 plus 4 plus 3. Do you understand why?
10.
To the power 8. You understand why not?
Mm-hmm.
You don't understand? Okay, 2 times
Yes,
5 is 10
I
times 10 to 8. 10 to 7, right? So the answer must be 10, 8. Only this guy gives 10 to the power of 8. Can you see? Here is 5 zeros times another 3 zeros behind. Can you see now? K means 3 zeros. So can you see the 8 zeros here?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. That's why the answer is D. Okay? All right, come. A body moving with a speed. Speed means what? V, right? Hello?
Yeah. KE.
Yeah. Oh, kinetic energy. Come, give me the formula kinetic energy.
Half times mass times
Kinetic energy is equal to
half times mass times speed square.
yes, mv squared, half mv squared. Oh, okay. So as kinetic energy 1800. So we just put in all the numbers lah. Come, teach me what to do, quick. All right, here is here. Yes, no. All right, equal half. Don't know the mass, right? He asked you what's the mass, right? Yes, no. Velocity we know, right? 30
square.
Square. Okay, go. Can you manipulate the mass? Come on, don't do anything. Come on, what must we do? This one must be 18000 times what? Times 2 divided by what? Before you punch calculator, write everything, but don't do your maths wrongly lah. Okay, the half goes up, the 2 goes up means what must we do?
180 over half.
Huh? Over half? Come on, the 2 goes up, right? Must be do what? From bottom, huh? Times what?
Times 2.
Ooh, then the 30 squared go down. The sun goes down, the stars come out. Hello?
Yes. 4.
30
GG,
squared,
4
Hey, 30 squared, I don't care. After that, you put calculator. I really don't care. What's
4.
that? Okay, I trust your calculator. You
Yes.
put wrongly, not my problem, Okay, come on, next one. The energy absorbed by a solar panel is used to charge a battery. Understand? During the day, the battery will store 1.6 joules of energy each second. That's what all the solar power panel is doing. Every time in the day, you know what they do? The sunlight shine on them, right? Then they charge themselves. So this solar panel is able to charge 1.6 joules every second. Do you understand or not? Do you understand what I'm saying? Oi.
Yeah.
You understand the question? The solar panel, very good, no? As the sunlight shines on it, is able to store 1.6 joules of energy into its like chemical potential energy battery. At night, no sun, electricity flowing out instead of flowing in. It's used to light a lamp. Understand a lamp? Hello? Okay. So what is your lamp? The lamp use 1.2 watt for so many seconds. Okay. All right. So what is the minimum time for the battery must be charged during the day? You must find how much energy the night needed. Okay, come. How much energy the night time needed? Energy at night needed. Energy needed. E-R-G-Y. Okay, needed at night. How much? Energy needed at night. How much? So at night, it charged the lamp. Energy needed. What is energy? What we know? We know is power is what? Do you know what is power? Power is equal to what? energy is power times time. Can you remember this?
W over times. Work
Yeah.
over time.
W over time. Right? So the energy needed, in that case, the energy needed is power times time. You want to use E or you want to W? E is equal to PT. How to remember is EPT?
Yeah, EPT.
Enough of playtime. You play too much. Yes, no. So your mother come and scold you. Suelon. So what she say? Enough of playtime. Get it? Enough of playtime. Can you remember?
Yeah.
Can you remember this? So I'm finding something to help you remember. Enough of playtime. So enough of playtime. So energy is equal to power times time lah. Yes, no? Not W lah. Cannot. Okay? Energy is power times time. Get it? So energy, now you know the power here, right? You know the time needed, right? Yes or not? So it's 1.2 times what?
Well, I can repeat.
Huh?
Well, repeat.
Yeah, I told you what is the energy needed. At night, the battery use so many watts for so long. So 1.2 times the energy needed is power times time.
1.6.
How come you know? 1.2 times where got 1.6? No, times the light the lamp for so long. Light the lamp so much. Lamp for so long. So what's the energy? 1.2 times what?
1.2 times 18,000.
Yes, lah.
I said that just now and you said no.
No, I didn't say no lah. Okay.
21,600.
Huh? 1,000?
21,600.
Oh, 21,600 joules is needed. Then this is needed, but in the daytime, the red color one, it only charge 1.6 per second. So how many seconds you need to charge? So this must be equal to 1.6 times the time, right? Because every second is 1.6. You need so much. So the time will be equal to what?
28,800.
Will be 21600 divide by 6. Understand this now? Oh, 1.6, sorry. Agree or not?
B.
B. Okay, guys? Come, we do the battery operated motor filling a block. Are you ready? Read lah. The diagram shows
The battery operated motor lifting a block of wood through 1 meter at constant speed. What is overall energy change taking place?
Overall, the key word is overall, from beginning to the end. Overall.
Electrical and no chemical.
Chemical, right? Because battery, don't be stupid, right? So this C and D don't pick, pick die, right? Because it don't start from electrical. What is the final?
Chemical into gravitational potential.
Yeah, because it lifted this one, right? Why Suelen so good? Okay? All right. When a force is applied to a box weighing 600 newtons, the box moves through 3 meters horizontally in 20 seconds. Power. What is power? I've got the power. What's the power? Power is equal to what? Power to
300 times 3.
Enough of playtime. Yes or not?
900. C.
Wait. C, Oh, you say one, I
think so. I'm pretty sure.
You're pretty sure. Okay. Teach me how to do. You say C, Okay, come. Tell me. How do you get it?
300 times 3.
Energy, right? What's the energy? Energy is work done, right? Right? Equal work done, right? What's the work done? The work done is, yeah? What is it? Work done is force times distance, right?
300 times 3.
Okay, which is what?
Wait, what? So 900 divided by 3. 300, 300. Oh,
300, right?
there's no 300.
No, 300, right?
Wait, no, wait.
Times the distance?
No, 300 times 3 equals to 900. And then
divide by?
20.
Divide by 20. So what's the answer now?
A.
Huh? Now it's A. Okay. A wave lifter lifts a total weight, okay? Through a distance of 2 meters. Yeah? 2 meters. I don't know.
What work is done?
2 meters. 15000. Total weight 15. Not one side each lah. Total. And yeah. Okay. What's the answer? C. It's so easy. Just take what? 15000, right? Which is Newton times the meter. Be careful, not kilometer. 2 meter. Okay, so the answer is C. I think I agree with you. Kiang. Hey, this is not nice, but this is the answer. Okay? See, this one. Apartment block receives water from a nearby reservoir. Can you see the reservoir is on top of a hill? Can you see? Hello? The pump is necessary to lift the water to a storage tank. Understand, people? To the top of the building. The gravitational field is 10 kg Newton. How much energy? Okay, can you just calculate yourself without looking at the answer first?
Okay, done. Did you pause the share?
No. Now can see? Can you understand? Do you know what is MGH? Potential energy, right? Gravitational potential energy is the formula mass times gravity times height.
Is equals to mass.
So what times what times what?
What's the G?
Disable. Gravity lah.
10.
There, this is gravity. G is here. Yeah, G is 10. Yes. Then each kilogram, see here, of water. Kilogram water, you know the mass, right? Kilogram. Each kilogram means how heavy? How many kilogram? Each kilogram.
I don't know.
Each kilogram means, right, times 10 Newton per kg lah, gravity. Do you know how water flows? If you have a container like that, shape of water, if they are connected like that, like, okay, container of water, if this is filled with water to here, how do I do it? And this is filled with water to like, okay, this is open. And this is like a S tube. Okay? Where do you think the level of water will be? What do you think? This level of water fill would be up to here, right? Okay, then how about this one, if they're connected? The water would be up to here, right?
Yeah.
Then this container would be like up to, I mean, because I stopped that guy, it will be, I mean, the base is up, would be up to here, right?
Yeah.
You know, then because the base is filled, it will be up to here, right?
Yeah.
Then because this is an S, what do you think? It will fill all these things with water, right?
To the same level.
Yeah, exactly, to the same level, right? Right or not? That's what my point is. Yes or not? Okay, my point is to the same level, right? Then do you really need to pump 50 meter high? Trick question, right?
40.
Do you need to really pump 50 meter high?
40.
Look at that. Look at that.
40.
40, my foot lah, because the water same height. That means if like that, the water will automatically fill itself up to here, but cannot stuck here.
Yeah, 40.
So you need to pump only 10.
Oh, bit.
Understand or not?
Uh,
Understand my meaning?
mm.
So you only need to pump 10. That's why very little to pump. You know, you pump 10 and it go up to the tank already. You don't have to 40 because automatic, the air pressure of water all the same height one. Do you understand what I mean? You need to pump 10 only. Get it or not? Because you understand water level is always the same height one. Can you see not? Yes or not? Get it? You understand? So this guy is here, so the same height. So the water, you don't need to pump one, it will come to the same height. Even though the pipe underground, the water pressure very good, can push it all to the same height. So you need to pump 10 only. Get it? So you need the 1 kg times 10 times what? Times how many more?
10.
Yeah, the height is 10. Yeah. Times 10, no? So it's 1 kg, right? 1 times 10 times 10, lah. Yeah, no? Hey, the meters are correct, right? We need to move in meters. Gravity is Newton. Mass is kg, right? So kg, correct. This is Newton per kg. Since you're kg, this is Newton per kg. And this is meter. Must move in. So 100 lah. Got answer or not? So it's B lah. Can?
Yeah.
Get it? Last one. Come, you want to teach me? Come on. Emergency generator supply so many joules for 24 hours. What is the average power output? Okay, I give you one clue here. Enough of playtime, okay?
So, right, first of all, we're gonna search for the energy.
So power is equal to, they want to find power, right? Is energy divided by time. Right? But the power is what? Time must be, energy must be in joules, time must be in seconds. Yes, not?
Yep.
Okay, what to do?
Ooh, I got it.
So what must I, what do I write? Power is equal to energy divided by time. Energy must be in joules. Do I know this?
Yes.
Yeah. Do I know the time? Be careful,
4 hours.
Yeah, so what is this? This need to convert this. They always trick people in this type of nonsense. Can you see or not? So how to do? What must we do?
24 times 60.
60 only?
Yeah.
Yeah, already? Really?
300,000.
Really? Why times 60? Can explain to me? 24 hours times how many?
60.
60 minutes, right? And then times how much?
Times 60 another one.
Times 60 seconds. Get it or not?
Yes.
Okay, then you put calculator.
5,000.
5,000. 5,000. All right, bye all.
Bye.
Thanks for watching, and if you like what you see, do give us a thumbs up, share and subscribe. And for more great tips like this, be sure to watch Science I Can Do.